Hello, I'm Jimmy Hosch, a member of the North Texas Renewable Energy Group, commonly referred to by our initials NTREG. I will be your guide in this video showing how to build the portable solar charger using a kit. This table of contents allows you to either watch the whole video or skip to a specific topic of interest. Middle school student Isabel Fripp and her father, Jon, an NTREG member, designed and built the first portable solar charger in May 2016. The kit we will use is a later design with lower component cost. We will start slowly, build the circuit diagram, and then follow the diagram as an assembly guide. Finally, we will make recommendations and present supporting data that will help you understand how to take care of and use the portable solar charger to power your personal electronics for years to come. But first, let's answer the question, what can I do with this power supply? It can provide enough electrical power to be really handy when the power grid is not available due to power outage or lack of physical access to the electric power grid. Dallas owners use the portable solar charger when the lights go out during storms. The two USB ports are useful for maintaining personal electronics like recharging cell phones and powering small LED lights. The 12-volt cigarette lighter socket will power low-wattage RV items like larger LED lights and fans. The lead-acid battery is a sealed unit and is maintenance-free. The small solar panel in the kit will slowly trickle charge the battery, but a larger solar panel, up to 120 watts, can be substituted to shorten the battery recharging time. The voltage meter and LED indicator lamps on the solar controller provide useful readiness and recharging information we will cover later. The power supply can be moved about, but weighing in at 9 pounds, including the 7 by 19-inch solar panel, it's portable in a backpack, but not in your hip pocket. A lead-acid battery provides the power in the power supply. The battery can deliver a maximum power of 7 amp hours at 12 volts. That means it can deliver 1 amp for 7 hours, or 7 amps for 1 hour, or any other multiple of amps times hours to equal 7 amp hours. It uses the same lead plates separated by water sulfuric acid solution as a 12-volt DC internal combustion engine starter battery. But instead of a liquid between the electrodes in each battery cell, a glass mat separates the electrodes. The liquid water acid solution is absorbed by the glass mat, thus the designation AGM, immobilizing the liquid solution and preventing spills. During the discharge cycle, the small amount of hydrogen produced from electrolyzing water is also absorbed in the glass mat and converted back into water during the recharging cycle. Because very little water is lost, the battery is maintenance-free. It has a long service life and can be deep discharged. One deep discharge cycle has 2 steps. First, start with a 100% charged battery. Use 50% of the battery's stored energy, then recharge it to 100% of the battery's energy storage capacity. An AGM battery is ideal for portable applications. I have drawn the electronic schematic symbol for each component within a brown box. This is the electronic symbol for a parallel plate battery. By convention, the negative terminal is connected to the outer short line. I remember it's the negative electrode because the short line looks most like a minus sign. The positive terminal is the one connected to the opposite long line and marked with a plus sign and a conventional red spot on the battery case. In all the drawings, I have used a circled X for the symbol of a connector. This battery has flat spade-type connectors. The last 3 components that comprise the power supply are each in a cylindrical case mounted with a bezel. A rocker switch is used for the accessory switch, which turns on the power to the output sockets. When the switch is closed, a milliamp level current will flow through the LED, causing it to light up, indicating the switch is on. In the center position, two USB sockets are above and below a voltmeter digital display. The digital display shows the voltage between the two terminals and is dark when the voltage is zero. We will discuss the use of the voltmeter later. The socket has miniature electronics in the package to convert the 12 volts from the battery to 5 volts required for USB. On the right is the standard cylindrical cigarette lighter socket used in automobiles. The outer metal cylinder is connected to ground, and a center contact is connected to the positive terminal. That's the shiny square in the photo. Many conversion cables are available for the USB socket. A cigarette lighter plug has a center spring-loaded contact and the leaf springs that hold the plug in place while expanding against the inside of the metal cylinder negative contacts. By adding 3 wires to connect these 4 components, we have our simple power supply. I have drawn this wire in red to indicate it would measure 12 volts relative to the return that is connected to the battery. When the accessory switch is open as shown, there is no voltage measured on this wire, so there is no power to the sockets. By closing the accessory switch, 12 volts is applied to the load sockets and the accessory switch LED is lit. The voltmeter is showing the battery terminal voltage, which I'll describe how to interpret later. This is all there is to the power supply portion of the portable solar charger. Only the solar battery charging circuit has to be added. The heart of the solar charging circuit is the solar battery charging controller. The diagram on the front of the controller maps the 6 connectors along the bottom edge. Both the solar panel and battery must operate at the same voltage, either 12 or 24 volts DC. The voltage is auto-selected before attaching the solar panel by attaching the battery voltage to the controller. The controller will feed charging current from the solar panel to the battery when the battery voltage drops, and stop current flow when the battery is fully charged, providing overcharge protection. When the sun is not shining, the controller prevents battery current flowing back into the solar panel, providing reverse discharge protection. The battery and solar panel terminals are short circuit protected and reverse polarity protected. Lightning protection is claimed, but the best idea is to avoid circumstances that might invite a lightning strike in the first place. This next picture shows how we will attach the solar charge controller to the battery. The battery attaches to the terminals 3 and 4. We have added a replaceable fuse to limit the maximum battery current. The battery switch allows us to easily connect the battery to the controller to auto-select the operating voltage before the solar panel is connected. Turning off the switch disconnects the battery from the circuit for storage. A cable with a solar panel connector is attached to connectors 1 and 2. Remember, the battery voltage must be applied to the controller to select 12 volt DC operation before the solar panel is connected. Closing the battery switch turns on the controller and the LED lights. I've colored the connector red to indicate it carries 12 volts when the switch is closed. The lit green load indicator means 12 volts is available on the load connectors. The portable solar charger does not use the load connectors. The two red battery lights below the wedge symbol for the battery state of charge means the battery state of charge is between 2/3 and 3/3 of full capacity. When all three red lights are lit, the battery charge is at full capacity. By charging any time you only have two LEDs lit, you'll get the longest battery life from your battery. When the solar panel is connected and exposed to the sun, the controller starts charging the battery and the green charging light comes on. This slide talks about when and why to use the battery switch. First, the battery switch makes it easy to set the controller up for the 12 volts operation by turning it on first and leaving it on when you take this unit out of storage for use for a while. But the last thing you must do after using the portable solar charger and before you put it into long-term storage is first fully charge the battery, then turn off the battery switch. Turning off the battery switch will stop the controller power drain. When disconnected from any load, a fully charged battery can be stored up to 16 months and only lose 50% of its charge due to self-discharge. Now we simply add this solar charging circuit to the battery power supply circuit developed earlier, and that will complete the portable solar charger. We can calculate the maximum current that our 10-watt solar panel can deliver. Power, measured in watts, is equal to the potential in volts times the current in amps. So 10-watt solar panel is equal to 12 volts times some number of amps. If we solve algebraically by dividing both sides by 12 volts, we can see that the number of amps delivered by the maximum number of amps delivered is 0.833 amps. That's 833 milliamps. Symbols are on the right. To estimate the battery charging time, we must remember that solar panels rarely deliver their maximum specified current. A better estimate is about 75% of what the specification calls for. So to estimate the actual current from the solar panel, we would say it's equal to 0.833 amps, the maximum, times 75%, 75 amps divided by 100 amps, is equal to 0.625 amps. So the estimated time to fully charge a nearly discharged battery would be 7 amp hours. That's how much energy the battery stores, divided by 0.625 amps, or 11.2 hours. Now, if a battery is only half discharged, it'll only take half that time, or 5.6 hours, to fully charge. So when you're using this, it is best to just leave the solar charger connected to the solar panel. You're much more likely to have too little power than too much. However, fully discharging the battery will likely ruin it, and you will have to replace it. I know, because I did that. What I'm going to do is to show you how to install the hardware that goes into the box. Pre-drilled holes are here for the connectors. That's all done for you. This is the solar panel cable. It has already been installed with a strain relief. So the first thing I'm going to do is install the bracket that holds the switch. Here's the bracket. You take a screw in the back side. Right here are two holes that are pre-drilled. Put the screw in from the back side, and then put the bracket over top of it and put on a nut. And then you've got to tighten those up. Probably the easiest way to do that is to hold the nut with a pair of pliers and screw the the screw with a screwdriver. The next thing we need to install are these switches and connectors. They fit with this bezel. Look at the bezel carefully. You'll see that on one side, on the back side, it has this little slot, notch. That notch has to accommodate this rubber connector. So it would go in here like this, and you have to be very careful that you've got this lined up in the slot, and this is in a little indentation. And you've got to be careful when you put these on, because they have a tendency to fall into holes in places that you don't need them. When you get done, when you get ready to assemble this, these should be extended out here. You can move them around. You can see them moving in the hole, and they behave like that. The next thing you do is screw it down. You align it with the pre-drilled holes, put the screws in place, and then make sure that these are still aligned, and make sure that they're in the right order. Here's going to be the rocker switch, then will come the USB connector, and finally the cigarette lighter. So, holding that in place, you simply open this box up and put the nuts on. There they are. They're installed, tightened. Now all you've got to do is to install your switches. You install these one at a time. And since it has to wind up looking like this, the switch goes in the right-hand position, on my right-hand position. Again, hold it with your finger, roll it back over, and this jam nut goes on the outside like that. What we're going to do is I'm going to rotate this around till it's oriented, and then tighten this up with a pair of pliers. And you do exactly the same thing for the other two. You drop them in, you put on the jam nuts. Once all of these are connected, all you have to do is attach the Velcro to the battery, insert the battery, push it all the way to the end of the box, and then push it to the side so that the Velcro sticks on. The last thing you want to Velcro on is the controller. You stick one side on by taking off the protective film, and take the other side off, and you're ready to install it. It's important where this controller goes. You want to make sure you don't cover up your vent holes. You've got vent holes here, here, and here, and it comes up through here as well. So this top edge should be right at the rounded portion of this panel. See that? So when it's installed, it should be centered on this panel at about that position right there. So your box has got all the hardware installed that's necessary to then start wiring up your control circuits. The next thing we're going to do is assemble the parts with this set of wires, the switch, into a box that already has some of the hardware installed. We're going to start off with the wires. We've got one straight wire, a red harness. Harness means that it's got at least a connector in the middle. Here's the third red harness, and then there's this black harness. If you look at the circuit, we're going to start with wire number 1, this one, and it connects to the switch. I've turned the switch around so you can see the prongs. These are called spade connectors, and this female goes on to either one of these males. It makes no difference which one, because when you close the switch, it simply shorts these two together. Now, one thing while we've got the switch out here, this switch has got a on-off signpost on it. It's this little disc right here. And if you notice, it's got a key in it. It will only go on one way. So we can look on here and tell whether or not the switch is on or off. So what we would like to do is assemble everything with this switch in the off position. Happens to be that way. So here I go. I'm going to put this on, just push it on. So one short wire connected. The next wire is the longest red harness, and we're going to take the end that has the fuse in it. This is the fuse. This is a replaceable device that blows out, burns in two if you put too much current through the wire. It happens to be a 7-amp fuse. If you put 8 amps through it, the fuse burns in two and disconnects the circuit. Second wire goes on to the second terminal. So we've got the switch connected. Now what we're going to do is simply install this switch into the box. I'm going to take this jam nut off. I'm going to take the little on-off indicator plate off, and I'm going to install it by putting it in here, holding it, put the keyed on-off switch plate on, and then take the jam nut and screw it on. And this should go on very easily just with your fingers. If it doesn't go on easily with your fingers, you've got it cross-threaded. You should stop, back it up, and start again. It should go down until it gets to be kind of snug with your fingers. And then it's snug but not tight enough for long-term use. And then we're going to take this pair of pliers and we're going to tighten that jam nut up just a little bit more. Good. So I've got the switch installed and the first two wires installed. What we ought to do next is let's put the battery in place. Here's our battery. Here's our positive terminal. We're going to just place it in here, put it down. It will have a Velcro attachment. We can Velcro it up to the side. The next thing we're going to do is attach this red wire. If you look at the circuit diagram at step number 2, we're not going to connect the controller at this time. This is the connector to the controller. So we're going to go to the end of the wire and go to the switch. There are 3 terminals on this switch. There's the one nearest you is brass colored, yellow brass. The other 2 are silvery or aluminum color or silver colored, shiny. And the incoming voltage, this is from the battery, is going to go on the inside terminal, the one right in the middle. So we attach it there. Let's finish the job of delivering the power to the rest of the devices. The other silver terminal is back here. I don't think you can see it, but it's the third one out here. It's on the outside, so going out from this switch, put that on like that. Now I take the next connector and look on here, it says plus. So it goes, this wire will go to the plus terminal, and I put it on. Like that. And again, this has a plus sign, so I put it on the plus terminal. Now I've got the battery power going to the middle of the switch, to the outer silver connector, to the plus sign, to the plus sign, so that all of the positive wires are connected. The next thing we're going to do is deal with the negative wire. This is going to go to the battery eventually. We're not going to connect it just yet. This is going to go to the controller. We're not going to connect it because we're not going to connect the controller. We're wiring up just the battery power supply. So the next thing that we need to connect is this terminal, this connector, to the brass colored spade connector. So I wiggle it on, and then it jumpers from this negative to this negative, like that, and finally to the third negative terminal. Unfortunately, these two have the plus minus signs on them. All we need to do now is to finish the wiring part of this, we want to make very sure this switch is in the off position so that we don't have any sparks and arcs. I'm going to take this black terminal, not connect it to the controller, but connect it to the battery. So what I'm going to do is I'm going to hold this up here so that you can see what I'm doing. And the black wire goes to the terminal that's not red, okay? The red indicates that's positive, this is negative. Black goes to negative. So I'm going to install it on the, like that. And now I'm going to pick up the other battery terminal, which is a battery wire, which is coming from the switch, this one. And I'm going to install it on the red terminal, the positive terminal of the battery. There we go. Making sure that this is always off, so we have no power applied to anything. Okay, at this point, we have assembled the battery power supply. The battery is providing power to the accessory switch and the USB plug and the cigarette lighter. And we've connected it to the battery. So everything is ready. All we have to do is throw the switch. And when we turn this switch on, what we would expect to see happen is power will surge down this wire and try to return on this wire. But if this switch, this accessory switch, is off, power won't get past the switch. So it's a two-step process. Turn the battery switch on first. That gets power to the accessory switch. Then you can see that the accessory switch light is not lit. So when I turn it on, you see it light up. You also see that here the voltmeter is now reading 13 volts, saying that the battery is charged, it's fully charged. I'm going to take the lamp that comes in your kit. This is one that will fit on your computer as well. And when I put it into this USB port, I expect this lamp to light up. And it does. So the battery power supply is assembled, tested, and proven to be working. The next thing we're going to do is connect power to the controller. What I'm going to do is use the Velcro connector and pull this controller off so that you can see it. The diagrams map to the connectors. What we want to do is attach the battery, this is the negative terminal, to that screw terminal right there. So what I'm going to do is I'm going to attach it here and hold it in place and screw it down. The next thing I'm going to do is wrestle with this red wire here. And to make that easy, I'm going to take this fuse connector apart, and that gives me room to work with this connector here, which is battery power. This is coming from the battery. Battery power goes in right there. I'm going to connect it here and tighten it up. The last thing I've got to do is connect the solar panel. Solar panel is right here. The red one goes to this first connector, and the black one goes to the next one over. And the red one goes on. Okay, so I've got the wires connected. I'm ready to put this back in place. You can see that I'm just Velcroing it in place. Now I'm going to take the fuse connector, put the fuse back in, screw the fuse back together, and now I've got continuity. Remember, when we turn the controller on, it's got to be looking at the battery. This controls the battery power. So I'm going to turn this on. I can see that the controller turns on. Turn it off, turn it on. The controller wakes up. It recognizes it has a 12-volt battery. It says that I've got load capability here, which is not used, but it's not charging. See that? So the last thing we've got to do is connect up the solar panel. After the controller knows what voltage from the battery, you connect up the solar panel. It begins to charge. So we're done. We've got a working power supply. I hope you have lots of fun with your new portable solar charger. With a little care and thought, your solar charger will last you for many years into the future. Now that you have a working portable solar power supply, I recommend you read the next slides that talk about how to get the most performance out of your battery. And there's a list of frequently asked questions that will talk about the general use and care of the power supply.